function to be differentiable, first of all, it has to be continuous. If it's not continuous, the function is guaranteed not to be differentiable. But even if the function is continuous, there is no guarantee that the function will be differentiable. But we have to start with this. This is our first step. So number one, I have to write that mx plus b and 4x squared are always continuous. And I'll say why. As polynomial functions. Now in step number 2, I have to discuss continuity at 1. Continuity at x equals 1. Can anyone refresh our memory on the definition of continuity at a point? What do I have to write? Continuity at a point. I'm plugging in my device because it's running out of juice. So can anyone give us the continuity, the definition of continuity at the point?
Is it that its limits have to be the same from both sides?
Yes, the limit from the left of 1 must equal the limit from the right of 1, excellent, must equal f of 1. Very good. So what do I put here and what do I put here?
X plus b equals 4x squared.
Awesome. So now, can anyone give us this limit? We apply the limit to this expression. Don't look here because it's not relevant. We apply the limit to this expression. What do we get?
-1.
Say it again.
So it's -1m plus b. So it's you don't really.
But this is not -1. The power means from the left.
Oh, sorry, 1. Yeah.
So this is m plus b. Do we all agree?
Yeah.
Perfect. What about here? What will this equal to?
4.
4. And of course, this is also 4 because I plug in 1 where the equal symbol is, and I get 4. So this is my first equation. And notice that it has two variables. So if m plus b equals 4, this function is guaranteed to be continuous. Okay. Now, I'm going to write f prime. And let's see. Don't look anywhere and just differentiate. Of course, it's with respect to x. So when we differentiate mx plus b with respect to x, what do we get? So of course, m and b are constants. The function depends on x alone. There is no other variable but x. These are constants. So when we differentiate this with respect to x, what do we get? Very good, awesome. Great job. So m, if x is less than 1. Now the same thing here. Don't look anywhere else, and please differentiate this, of course, with respect to x.
X.
8x, very good, awesome.
8x.
So I cannot include the 1 yet. So now, what has to happen, so this is item 3, for this function to be differentiable, the limit from the left of 1 must, of the derivative, must equal the limit from the right of 1. And you can say, are you making this up? No. So if the function looks like this, the function is continuous, but at this point, it has two tangents. If you want three, but that's not the case, it has to follow the function. Doesn't matter. So it cannot have a corner, no corner. So this condition about the derivative means this. The tangent from the right is the same with the tangent from the left. In other words, the slope here equals the slope here. Slope here cannot equal the slope here because it's a corner. But now the last condition I have to come up with is unique. In other words, only one tangent. In other words, the slope on this side has to equal the slope on this side. In other words, one tangent, not two tangents. So that's why the limit from the left of one of the derivative, which is m, has to equal the limit from the right, which is 8x. Nothing else here. We only want the limit from the left of the derivative and the limit from the right of the derivative to be the same. In other words, there is only one tangent with one slope. The left-hand side, m, the right-hand side, 8. And this is our second equation. We have the first equation, and we have the second equation. And this is a system. And if I plug 8 in here, how much is b?
-4.
That's it. So now it's guaranteed the following function, f of x equals m, which is 8, 8x minus 4 for x less than 1, and 4x squared for x greater than or equal to 1 is guaranteed differentiable on negative infinity to infinity. Guaranteed. First, we made it continuous at 1 with this equation. And secondly, we guarantee that there is only one tangent. The slope on this side equals the slope on this side, because here the slope on this side does not equal the slope on this side. This is much steeper than this one. It's not the same. But here it's just one. One slope, one tangent. Very good problem. Is this okay, Tess?
Why did you write m equals 8?
The limit of this, as x approaches 1 from the left, must equal the limit. This tangent, this slope has to equal this slope, must equal this. When I plug in 1, I get 8. When I plug in 1, I can plug in anywhere. So m must equal 8. So then m plus b equals 4 from continuity. And from differentiability, m must equal 8. Then I plug in, I replace m by 8, move 8 to the other side, I get b equals -4, and these are the two branches. And now it's guaranteed that this particular function is definitely continuous. We made it continuous with this equation, and now it's also differentiable that we guaranteed with this equation. And then we determine b and m, and we put them back in the function. And now we know that this function is guaranteed to be differentiable, of course, continuous. That's differentiability is even stronger than that. It guarantees continuity everywhere. Good. That's a good problem.
The difference between number 3 and 2.
This is for continuity, and this is for guaranteeing one slope, not two slopes. One slope. The slope on the left equals the slope from the right. This one does not say anything about slope. Continuity doesn't have anything to do with the slope of the tangent line. Differentiability has everything to do with the slope of the tangent line, but not continuity. Showing continuity, the limit from the left must equal the limit from the right, must equal the function value. Differentiability is something else. Differentiability means A function is differentiable if it has only one tangent. To the right of the point, the slope is 5. To the left of the point, the slope is 5. It means that there is one tangent, which means the function is differentiable there. Is this okay?
For me, yes, thank you.
Good, very good. So now, anything else, or can I continue with the last two sections? 1.7.
I have a question
Say-
for 1.6, MATLAB math, question 20.
So you said 1.6, number 20?
Yeah.
Okay. Okay, so let's see, where are we here? 1.6. 1.6, number 20. Okay, so let's see number 20. Okay, so the population being thousands of a small city is given by the following function, where t is time in years. Answer part A through C. I don't think I can see. So find the growth rate. The growth rate is. So here in part A, we're just asked to find the derivative. So P of t equals 500t divided by 2t squared plus 9. We had a similar problem last time. So we wrote it like 500t divided by 2t squared plus 9, and we just differentiated. So always start by reviewing what we did in class. It will save you a lot of time. Maybe you did. Maybe you just need help on this. So P prime of t equals 500. We use the quotient rule. T prime is 1, so multiply by 2t squared plus 9 minus t times the denominator prime, which is 4t over 2t squared plus 9 squared. Was this a problem, or was it the problem here with the differentiation, or?
No, it was towards the last one, like question C.
Okay, so 4t squared minus 2t squared is minus 2t squared plus 9 divided by 2t squared plus 9 squared. I don't like negative leading coefficient. 2t squared minus 9 over 2t squared plus 9 squared. What was the second part of the question? What was the part 2? What was part B and part C? So this is part A and this is part B. Do you remember what it was?
No, I'm trying to open it.
Okay, you have to type this in so it can let me populate. Oh, I see. It's asking, okay, it's the same problem we did in class. It's asking you to find the population after 12 years and the rate of change after 12 years. That's all we need to do. We did a very similar problem in class.
So like for C, right? So I plugged 12 in for the equation, and I got like the decimal point. And anytime I put it in MATLAB math, it always tells me like I need to move the decimal point. If that makes sense.
That's because you have to multiply it by 1,000, because it's 1,000 of the population, thousands of the population.
Oh, okay.
So
Thank
P is
you.
in thousands. Yes, P is in thousands. So you have to multiply by 1,000. Is that
That
okay?
was the problem. Yeah, that's it.
Okay, very good. Awesome. Thank you. Very good. Anything else, anyone? Okay, so as I said, we have 2 more sections to look at. Let me start.